All right, let's talk about a couple things that are going to be on your test about the periodic table. So you do need to know how everything is arranged and why things are the way they are and group names. So easiest thing to do is first find this stepladder that's red in the classroom on the classroom wall periodic table. What this tells us is basically it separates our metals on the left from our nonmetals on the right. Okay, so if you find this line, the zigzag line, everything on the left is going to be a metal, everything on the right is going to be a nonmetal. The only exception are going to be all of the elements that touch that zigzag line are what we call metalloids. They have properties of metals and nonmetals, not including aluminum here, but I promise not to ask you that on the test. So all of our metals, all of our nonmetals, and then our metalloids touch the line. Now, a couple other things that were on your study guide that you need to know are where the transition metals are. Everything in group 3 through 12 here are transition metals. And then you also need to know the name of a couple of groups. Let me focus this a little better. You need to know the names of group 1 elements. So group 1 elements are here. These are what we call alkali metals. Group 2 elements are called alkaline earth metals. Okay, so we've got alkali metals group 1, alkaline earth metals group 2. Over here in group 17, we have halogens, and group 18 are noble gases. Okay, down on the bottom, we have our lanthanides and our actinides. And if you have a hard time memorizing those two, the first element in the group is lanthanum and actinum. So you can remember the lanthanides and the actinides. Okay, so those are just the basic things on the periodic table of what you need to know. Alkali metals, alkaline earth metals, transition metals, halogens, noble gases, lanthanides, actinides, and then the line that separates all of our metals on the left from our nonmetals on the right. And if it touches this line, it's going to be called a metalloid. A couple other things that we talked about with the periodic table are group numbers and what that corresponds to. So if you look, this is group number 1, 2. We're going to skip over our transition metals and groups 13, 14, 15, 16, 17, 18. What's significant about the group number is it tells us the number of valence electrons an element has. So group number 1 has 1 valence electron. Group number 2 has 2 valence electrons. Group number 13, 3 valence electrons, and so on. 4 valence electrons, all the way up to 8 valence electrons, and that's why noble gases are considered chemically stable. They have a full shell of electrons, which would be 8. Remember, that's the octet rule. So 1, 2, 3, 4, 5, 6, 7, 8. That's how you know how many valence electrons an atom has, just what the group is. Elements in the same group have the same number of valence electrons, which makes them react chemically the same way with other elements. So all of the alkali metals are super reactive with water. Okay? That's one of their chemical properties. All of the noble gases are pretty much unreactive because of that full valence shell. So the number of valence electrons you can figure out by the group it's in, and then the group number will also tell you that that group has similar chemical properties. The last thing that people seem to be having problems with is, how do I know what charge it has? Well, remember, there's 2 things that an atom can do to become an ion. An ion is a charged atom. Make sure you know those terms. So an ion is a charged atom, and in order to become charged, it's either going to gain electrons or lose electrons. If it gains electrons, it gets a negative charge, and if it loses electrons, it's going to have a positive charge. The hardest thing is probably figuring out, okay, well, what is it going to do? I'll give you a hint. If it has 1, 2, or 3 valence electrons, so 1 to 3 valence electrons, that atom is pretty much going to lose all of its electrons to become a positive ion, which we call a cation. Okay, so 1 through 3 valence electrons, so groups 1, 2, and 13 are all going to lose their electrons because it would be way harder to gain enough to get up to 8. So they're just going to lose their valence electrons to become a cation. And remember, a cation has a positive charge. That means that they're going to have fewer electrons than protons. You cannot change protons, you can only change electrons. Now, groups 15, 16, and 17 are going to have 5 through 7 valence electrons, which means they're going to gain electrons to become an ion. They're going to gain electrons to become an ion, and if you gain electrons, you become an anion, which has a negative charge. Okay, so for example, group 15 has 5 valence electrons. It only needs 3 more electrons, valence electrons, to become chemically stable. So it's going to gain 3 more electrons to be like a noble gas and have a negative 3 charge. Okay, so 5 valence electrons would give us a negative 3 charge. If I have 6 valence electrons, I need to gain 2 more to get to 8 to have a negative 2 charge. And if I'm in group 17, I need to gain 1 more for a negative 1 charge. So groups 15, 16, and 17 are going to gain electrons to become a negative ion, to become more like noble gases. And if I go back to the positive ions, or cations, groups 1, 2, and 13, like we said here, are all going to lose electrons to get a positive charge. Well, if I lose 1 electron, I'm left with a positive 1 charge. Or if I lose 2 electrons, I'm left with a positive 2, and lose 3, I'm left with a positive 3. Now, I know this looks like a mess, so you may have to watch certain parts of the video, rewind, do whatever you need to do to watch the couple parts over again. The first part was where everything is. The second part has to do with the group number it's in, and then the number of valence electrons, which helps us figure out the charge.